Okay, so welcome guys. So this video is just a very short video. I want to introduce the Planck unit. Okay, so I will not spend a lot of time. I mean, like in the Wikipedia, like people like computing all the Planck units, right? But I just want to derive 4 of them. Okay. Okay, so the idea is that I mean, the high energy physics, people are probably not a little bit lazy, so you will see something like this. Right, so some smart guy in high energy physics will define their h bar to be 1, so the Schrodinger equation become very easy. Okay, and the special relativity become very easy if you claim C to be 1. Okay, and your general relativity become easy if G is 1, and also your statistical physics become easy if KB is 1. Okay, so all formula become all formula become easy when you set all of these famous probably the natural constant showing the world to be 1. Okay, so but what is what is the meaning of this, right? So the meaning is that actually if you set all to be 1, then there's a conversion, right? So basically you're living in the Planck length and the Planck mass and the Planck time, also a Planck temperature. Okay, so the idea is that if you set all to be 1, right, there should be a conversion between your original SI unit to this Planck unit. So Planck unit should be viewed as the natural unit if you set all of these constant to be 1. Okay, okay, so this is just the very introduction. Okay, so now the rest of videos just want to derive this. Oh, what? Okay, I should clean this. Okay, just want to derive the unit. Okay, so I mean there's a 4 natural units, right? If you first learn the physics, you know that there's a length, mass, time, and temperature. Okay, so because time temperature will coincidence. If I use T, it will coincidence of time, so I use Q as a temperature. Okay, just for fun. Okay, so the goal is to derive all this. Derive all this expression from unit analysis. So probably this is like the most important one. Basically, if you go to study like the subject GRE, then you will see some people ask about this type of question. Okay, so the first one is that we need to first write down these 4 guys, right, as a natural units. Okay, so maybe we start from the C. So what is the unit of C? So speed of light, right? So will be the length divided by time. Okay, and what is this H? So this H bar, right? Remember H bar is the unit of H bar is the same as the action. So will be the energy times the time. Okay, so if you take about unit, right, and the energy you can view is mv squared, right? So it's mv squared times time, right? And what is v squared? V squared will be L squared divided by time times t, right? So this is the unit of the Planck scale. So ml, I should say ml squared divided by t. Okay. Okay, and the third one is the third one will be we will use will be g, right? So remember that we have formula that f is gmn divided by r squared, right? So I can write f as ma because I only care about units, right? So I can cancel 1m. So g will be the acceleration. So acceleration will be l divided by t squared. Let's say times l, right? L squared divided by m. Okay, so g should be l to the cube divided by t squared times m. Okay. Okay, so now we have 3 units, right? So first one, second one, and then we have the fourth. Basically, it's a KB unit. Also, quick derivation. So one energy will be kBt, right? And this is just ma. Also, it's mv squared. So it's the same. It's basically let's say m L squared divided by t squared divided by the Q. Okay, Q is the temperature. Okay. Okay, so we now have 4 of them, right? So we can prove what this is actual Planck length. So the proof. Okay, so the Planck length defined to be LP divided by h bar g divided by c cubed. So let's verify the LP is correct. Okay, so let's say h, right? You get that's quicker. I omit the bracket, right? Because it's time consuming. So it's, let's say ml squared divided by t times g. So it's l cubed divided by t squared divided by n divided by c squared. So it's l cubed divided by t cubed. Okay, so you see these m and cancel. You get l to the 5 t l to the 5 divided by t to the 3 divided by l to the cube divided by t to the 3. So you see this is l squared, take a square root, which is l. So this is indeed a length. So we prove this one. Okay, how about that we prove the second one? Maybe I write here. Okay, so the second one is what MP, right? So it's mass. So MP defined to be, let's say, h bar c divided by g. Okay, so h bar will be ml squared divided by t times l divided by t divided by g, right? So g is ml squared divided by, oh sorry, g will be l to the cube divided by t squared m. Okay, and all of in a square root. So we see right, so l cancel and tt cancel, and we get m squared, which is exactly the unit of m. So we proved the second one. Okay, so finally let's talk about the third one. Basically, it's the time. So the TP. So it's h bar g divided by c to the cube. Okay, so let's shrink a little bit. So h is still ml squared divided by t, right? So it's ml squared divided by t times g. So g will be l to the cube t squared divided by m, and then divided by c to the 5. Okay, so this is very large. So it's l divided by l5 t5. Okay, so we see l cancel, right? And m cancel, and we get t to the cube, right? And the t to the 5. So this is t squared t. Okay, so the first three are exactly the same. Exactly correct. Okay, and finally, I think I don't have the proof here, right? TP is basically hc to the 5 divided by g. So hc to the 5, h bar c divided by g kb squared. Okay, so let's prove the final one. Okay, maybe I can link some portion to prove. I think everybody knows what's the hell going on, right? So final proof. So finally, is this the temperature Tp, right? Defined to be h bar c to the 5 g kb squared. Okay, so let's write down all the units. So h bar will be ml squared divided by t times c to the 5, right? So it's l to the 5 t to the 5 divided by g, which is l cubed t squared m times kb squared, right? Very scary. So it's m squared, l to the 4th, t to the 4th, which is cube squared. Okay, so we hopefully we are smart enough. So we see this m will become m squared. So m squared cancel with this, right? And the l to the 7 cancel with l to the 7, and the t6, so become a cube. Okay, so we prove this. We prove these 4 Planck units are unit correct. So they are unit correct. Okay, so the easy idea is that once you have the L, M, LP, MP, TP, and the TP, then you can define all the unit, all the other unit, divide all other units. So for example, if you want to divide the so-called Planck energy, then you can divide like mv squared or something. And basically, if you want to define a Planck momentum, you can define mv, right? Mv just be mp times lp. Okay, so this is a very short video about how to prove all this, why these 4 units are written in this way, and I provide all the details. So subscribe to my channel. Hope to see you guys in the next video.